Okay, so we are back here, and now what I've done is I've rotated the blades, as you can see, so that the blades make a distinct angle with the plane of the rotor. In this case, I would estimate my angle is maybe about 30 degrees or so, and I've done the same for all the blades. So now when I blow wind on the turbine, there we go. The blades actually spin very nicely and generate electricity. So let's try to understand what is happening here. So when I look at my blade, I can see my blade making an angle to the rotor. So basically what is happening when the wind blows on the blade, the net force that is produced by the wind has one component that goes back and one component that goes that way. Because the net force acting on the wind is always going to be, the net force produced by the wind is always going to be perpendicular to the plane of the paper. So the net force acting by the wind is that way. There's one component that way, one component that way, and that component causes the blade to spin. Now in an aircraft, these components are called lift and drag. And of course, lift and drag really depends on what perspective you take, but let us, for our purposes, call this component lift and that component drag. So basically, when we had the blades sitting perpendicular to the wind, we got no lift and we only got drag, and that's why the turbine didn't spin. But once we turned the blades a little, we got drag and lift, and it's actually what we're calling the lift component that actually makes the turbine spin. And this is exactly the same principle that airplanes use to fly. Because the wing of the aircraft makes an angle to the wind, you get one force that wants to lift the aircraft up and one force that wants to push the aircraft back. This is called lift and drag. Lift pushes the aircraft up and drag pushes the aircraft back and is actually overcome by the thrust of the engines.